Good morning. This is your Stat Sensei, Mr. Spensei, and this is Death Packet on proportions, and this is problems 51 through 60. A one sample test for a population proportion, it should have said Z-test, for a population proportion will be conducted using a simple random sample selected without replacement from a population. Which of the following is a check for independence? All right. NP greater than or equal to 10 and N times 1 minus P greater than 10. This is for normality, and they wanted independence. So that doesn't look like it, our answer. Each sample proportion is less than or equal to 0.5. I don't even know what that means. The sample size is more than 10 times the population size. We never check that. That's backwards. That's wrong. That's not even a condition. The population size is more than 10 times the sample size. Yes, that's why we always go n times 10 has to be less than the population. This is our independence. All right. 52. Is the significance level of a hypothesis test equivalent to the probability the null hypothesis is true? Alpha is our significance level, and alpha is the probability of committing a type 1 error. So no, that part's not true. And alpha and type 1 error is the probability of rejecting the null when it's true. No, the significance level is the probability of rejecting the null hypothesis when the null is actually true. So the answer to 52 is actually A. 53. Which of the following is a true statement? Tests of significance are designed to measure the strength of evidence against the null hypothesis. Yes, that's 100% true. That's what we're doing. We're gathering evidence and it's telling us how good it is. So, a well-planned test of significance should result in a statement either the null is true or false. We never prove that the null is true, ever. So that's what's wrong with that one. The null hypothesis is one-sided and expressed using either. No, the null hypothesis is always an equal statement in AP Stat. When a true parameter value is farther from the hypothesis, it becomes easier to reject the alternative. No, it becomes easier to reject the null. Increasing the sample size makes it more difficult to conclude that an observed difference between the that an observed difference between an observed and hypothesis is significant. No, it doesn't make it more difficult. It makes it easier. If there is a difference, increasing sample size makes it easier to note that difference. So our best chance answer to 53 is A. Number 54. An office manager believes that the percentage of employees arriving is even greater than the previously, and I think it's supposed to be a lot arriving late, is even greater than the previously claimed 7%. She conducts a test on a random sample of 200 employees and finds 23 arriving late. Is this strong evidence against the 0.07 claim? Well, basically they're saying, hey, you know what? What's our p hat? She took the sample, and the sample was 23 out of 200. So let's go ahead and run the test. And we can do this on the calculator very fast, although we could set it up. Let's go stat test, one proportion z-test. The claim is 0.07. The x is 23. The n is 200. And she says she thought it was greater than, because in this case, our null is p equals 0.07. And the alternative is p is greater than 0.07. So that's what we have. And we ended up getting a p-value of 0.0063. I don't see 0.0063. here, but I see 0062. That's a pretty small p-value. Now, they didn't give us an alpha level, but let's just say they'd given us an alpha level. So we have a p-value and we have an alpha. Let's just say their alpha is 0.05. This is 0.0062 or 63. Well, this 62 is definitely less than 500. If that's the case, I'm rejecting. Why? Because I have a lot of evidence. All right. So 54 is A. 55. Which of the following is an incorrect statement? The sampling distribution of X bar has a mean equal to the population mean, even if the population mean is not normal. No, that's a true statement. The mean is the mean is the mean. The sampling distribution of X bar has a standard deviation of the population divided by the standard deviation of the population divided by square root of n, even if the population is not normally distributed. That's true too. The sampling distribution of X bar is normal if the population has a normal distribution. Well, that's also true. The sample will always look like the population. When n is large, the sampling distribution of X bar is approximately normal, even if it's not normally distributed. Now, I didn't say how large the sample was, but assuming it was n greater than or equal to 30, that's true too. All right. The larger the value of the sample size n, the closer the standard deviation of the sampling distribution of X bar is to the standard deviation of the population. That's false. Here's why. This is the standard deviation of the population. The standard deviation of X bar equals the standard deviation of the population divided by the square root of n. So as n gets big, this is going to get small, and it's going to be much smaller than that because that's not divided by anything. All right. So as n gets big, this gets small, which will make it smaller than that. So this is what's false. 55E. 56. A 2007 survey indicated a survey of 980 American drivers concluded that 38% of the driving population would be willing to pay higher gas prices to protect the environment. Which of the following best describes what is meant by the poll having a margin of error plus or minus 3, a margin of error of 3%? Well, first off, remember, this is our p hat plus or minus the margin of error. That's our formula. So 0.38 plus or minus 0.03. If I subtract 3, I get 0.35. If I add 3, I get 0.41. So the margin of error lies directly in between there. I mean, not the margin of error. That's where our inner confidence interval is, and 38% is dead in the center. So, basically, what this says is if we are 90, I don't know what this confidence level was. What's the best describes the margin of error? All right. 3%, that's just a giveaway. We know that's not right. It would not be unexpected for 3% of the population to be readily agree. No, it's not 3%. We'd expect somewhere between 35 and 41%, right? Between 343 and 402 other drivers responded. We don't care about the sample. We're not, our confidence interval is not about the sample. It's about the population. A similar survey of 980 drivers was taken. A 3% change in each week's, that doesn't make sense. It's likely that between 35% and 41% of the driving population would be willing to pay higher gas prices. Yeah, we don't know where, but it's likely somewhere between here. And they said it's likely because they didn't know how confident they were because they didn't tell us the confidence level. 57. Last year, it was calculated that the recreation expenditures were 8.7% of total personal consumption. An economist believes that this percentage is going up as we move further out of the recession. Consider a hypothesis test P equals 0.07 versus P is greater than 0.087. Which of the following choices of which in the following choices of significance level and sample size result in greatest power? Well, let's talk about power. Well, power goes power goes up as int goes up. That's for sure. Power goes up as alpha goes up. All right. So in this case, since we're dealing with alpha and power, we want the biggest alpha and the biggest sample size. Well, that's and then I look and they go, oh, 30 is bigger than 20. My best choice for 57 is D. 58. Suppose that 35% of all business executives are willing to switch companies if offered a higher salary. If a headhunter randomly selects a simple random sample of 100 executives, what's the probability that over 40% will be willing to switch companies if offered a higher salary? Well, HO, let's draw a picture of this one. I think that'll help. First off, here's where our mean is, 0.35. Now, our mean happens to be a proportion, and we want to know, having a 0.40, of getting a sample mean or a sample proportion of that. So in this case, Z equals P hat minus P over P times 1 minus P over N. Well, I can't plug that into the calculator very simply. Now there's some tricks to this that we could use, but I prefer not to be tricky. I'm just go straight forward with it, which will take me a little bit longer, but I think it'll help. So P hat equals X over N. Well, they just said P hat's going to be 40%. So 0.40 equals X over 100. So when I do that, when I multiply that out and I go 0.4 times 100, I'm going to find out that X is 40. All right. So X equals 40. Now, when I go to my calculator to plug this in, I'm going to go stat test one proportion Z test. P, the claim was 0.35. The X we just found was 40. The sample size is 100. And we're obviously shading to the right because we want to be as extreme or more extreme. See if I, wrong way. I don't know if that helped much, but anyway. So I end up getting a p-value of about 0.1472. All right. So 0.1472, I don't see that exact answer there, but for 58, the closest one is 1469. That's pretty close. So I'm going to go with that's my best answer. All right. So 58 being A. 59. Given that 58% of all gold dealers believe that next year will be a good one to speculate in South African gold coins, in a simple random sample of 150 dealers, what is the probability that between 55 and 60% believe that it will be a good year to speculate? So, what we're looking for, and this is kind of a weird problem, is this is 0.58, this is 0.55, and this is 0.60. So we want to know the probability that we're going to be somewhere between these two areas. Well, in this case, I have a lower and an upper, I believe. And I also have a mean because, um, and, and I'm going to pause while I think about the best way to explain how to approach this problem. So I'm going to pause for just a moment. All right, I think I have it figured out, guys. I sure hope I know what the answer is going in, but I sure hope I'm doing this right. We'll see real quickly whether I'm right. So I know that, hey, you know what? I'm looking for this range. What I need is a standard deviation because I know the population proportion is 0.5. Well, the standard deviation for P is equal to P times 1 minus P over N. So equals the square root of 0.58, because that's what the claim was. So we believe it to be true, times 1 minus 0.58, which is 0.42, divided by the sample size of 150. So let's take our calculator, not 1500, but 150. So let's do that. 0.58 times 0.42 divided by 150. And I'm going to raise that to the half power. And I get 0.04029. So I'm just going to call it 0.0403. All right. So I'm going to say my standard deviation for P equals 0.0403. Well, it's been a long time we've done this, but anytime we've shaded something like this, we kind of, and it was normal, we want to go to norm CDF, in which case our lower bound was 0.55, upper bound is 0.60. We have, this is my lower, this is my upper, then I have my mean of 0.58 and a standard deviation of 0.0403. And we can hope that I did all that right. So here we go. Second vars, norm CDF, lower bound 0.55, upper bound 0.56, mean of 0.58, and we have 0.0403, and we get 0.4618. Pretty close, not exact, but that's definitely really, really close. And that is the correct answer. 60. In a random sample of 1,250 adult drivers, 450 said that they would be cut their driving by 10% if this significantly helped the environment. Find a 95% confidence interval for the estimate of the proportion of adult drivers who are willing to cut their driving by 10%. All right. So first off, we have to find P hat. Well, since all of these start with 36, I'm going to assume that that's what it is, but let's go ahead and check because P hat equals X over N. So P hat has to equal 450 over 1,250. 450 divided by 1,250, and that's 0.36. So that's where our P hat is. It's 0.36. All right. So confidence interval has the formula P hat plus or minus Z star P hat times 1 minus P hat all over N. So in this case, 0.36 plus or minus, we'll have to figure out Z star in just a second. Oh, they use all of them are the same, so we don't have to worry about it, but we'll still do it anyway because it's good practice. And this is 0.36 times 1 minus 0.36, and 1 minus 0.36 is going to be 0.64 over N, and N was 1,250. All right. Now, second VARS, inverse norm. They said 95%, so 0.95. And there it is, their 1.96 that we needed. All right, so that's wrong. That doesn't match. That doesn't match. And the one that does match, now this is close, but remember that radical has to come all the way down. So this is wrong because the radical doesn't come all the way down. So the answer to number 60 is D. All right. This concludes this video. I appreciate you for watching. Thank you.